So in our foldable for the rules of exponents, and this is going to start our lesson for geometry 1.5, there's something that we didn't do yet, and we're going to want to talk about it today, because now that we've done simplifying polynomials and rules of exponents, sometimes these things cross paths. Right now there's all multiplication and division in here. Do you see any addition or subtraction? No. So I don't have expressions or terms, okay? They don't have terms. There's no terms in there. Those are just each their own factor. Notice the rule is power of a product or power of a quotient. So that's when I distribute this exponent to the other exponents. You may have a problem like this. A plus b, and I'm just going to do it squared so you can see it with a number right now. Is that all multiplication and division? No. I cannot use power of a product or power of a quotient rule when those things are not multiplied together or divided together. What does this actually mean? This 2 means that there's how many of these? 2 what? 2 factors of a plus b. Will that be the same thing? Right? I have people all the time who do this and they tell me, oh, Mr. Ritter, that's a squared plus b squared. No, it isn't. That is wrong. Because when you expand this, a plus b times a plus b, you're actually going to get a squared plus, I'm going to do it this way, ab, I'm going to always put it alphabetical order, and now I'm going to do the b times a, which would be ba, but if I'm writing it alphabetically, it's ab again, and then b times b, which is b squared. So that's actually a squared. There are 2 of those, so plus 2ab plus b squared. It is not a squared plus b squared. There is a middle term. Okay? So if there's a plus sign inside and I have an exponent on top, I cannot use the power of a product rule or the power of a quotient because it's a plus sign. I have to expand it. I have to write out how many factors. So the tip for this, to avoid the common error, you need to write out the factors. And then you can remember to use your distribution property for the terms themselves, not for the exponent. We're looking at 1.5 today. That's something I wanted to point out to you first so that you don't make that mistake when we get to some stuff in 1.5. So here's our notes for 1.5. Our learning targets, and this is back to geometry, but we're going to use some of the things that we've taken the time to go back and do in algebra. We need to be able to apply formulas for perimeter, area, and circumference, both for numerical values and for variable expressions. We need to be able to solve a formula for a given variable, which we've done earlier, but now we'll have other formulas, and use the result to solve a problem. Who can give me a definition of perimeter or perimeter? What about the outside? The measure, the distance around an object. Distance around an object. Now there are some specific formulas that we can follow for this. You don't really need all of them because if you had sides or that you could draw a picture and label, you just add all the sides together. But one of them is the perimeter of a rectangle. Does anyone remember what the perimeter of a rectangle is? 2 times the length plus 2 times the width, because there's 2 long sides and 2 widths. Okay? That's one. If you didn't remember it, it's okay because you would just, hey, whatever this is, whatever this is, add all 4 up. You're fine. There's also the perimeter of a triangle, which sometimes could include its height, but not always. We have to be very careful. On that, we're going to call B the base, and then the other sides are A and C. h will be our height, which sometimes could coincide with a and c, but only on a special triangle. Our height has to be perpendicular to the base. But the perimeter for this would be just add the sides, a plus b plus c. There's also a formula for the perimeter of a square, but I'm going to be honest with you, I don't memorize it. I just know it. Because if I added all four sides and all four are the same and one side is called s, then how am I going to get it? It's going to be 4 times s, 4 times one side. I'm not going to require you to know these perimeter formulas. If I give you one, you might have to solve it or use it, but otherwise, you know how to add up sides to get the perimeter. I think you could draw a picture to figure those out. Area is a little bit different. Oh, by the way, perimeter is measured in linear units. Linear units of measure. So that by linear units of measure, I mean like inches, feet, centimeters, miles, kilometers. So yeah, it's not just a line, but I'm going a linear path on each of these. And I could stretch them out to make one big line to see what's the total distance around the object I went. We're talking about distance, which is linear. We can measure with a linear unit. Area is not a linear unit. It is a two-dimensional measure. Okay. And so we could look for a more formal definition, but when we're looking at the rectangle, we're not looking at the sides, we're looking for the shaded region. How much of that shaded region do we have? How do I find the area of a rectangle? Base times height, or some people call it length times width. It's the same thing. On a parallelogram, it's the same thing, except it's slanted, so it's not, it would still be base times height though, or yeah, not length times width in that case. Area of a square, well, it's still length times width, right? But now both the length and the width are s. So what's s times s? S squared. I don't require you to memorize that formula. If you know a square is a rectangle, just do length times width, you'll get the same answer. And the area of a triangle. Yep. It is half the base times the height because, see our rectangle? All I would do is draw a line to cut that in half, and I now have a triangle. It's still base times height, but I only have half of the shape. So half base times height for the triangle. There is one other area you need to be familiar with. This is one that you will want to know. We're going to use it a lot, particularly in the second semester. The area of a circle. Anyone know it?
Yes.
Pi times radius squared. And how I remember that it's radius squared and not 2 pi r is area is a two-dimensional measure. And so because it's a two-dimensional measure, my units are not linear units. They are square units of measure. Like inches squared, centimeters squared, feet squared, miles squared. Okay, so perimeter is linear units, area is square units. What do you think volume would be? Cubed units, cubic units, which we'll get to later. We're not there yet. Inches squared, centimeters squared, feet squared. So square units when we're talking about two-dimensional measuring. Circumference. I don't know why we didn't just put this under perimeter. I accidentally did it in first hour. Circumference of a circle is the distance around the circle, right? So what's that closely related to? It's the perimeter. If I said, what's the perimeter of the circle, you'd all look at me like I'm weird because we don't say that. The circumference is the perimeter. But perimeter is usually, hey, there were linear measurements and we added them all up. The circumference was a big curve that we could stretch out into a straight line and would also be linear units. And some people memorize the perimeter of a circle or circumference of a circle as 2 pi r. There is a direct relation between that and the area formula that you'll see when you get to calculus. But right now, I don't memorize it as 2 pi r. I know that the area is squared, so I'm going to use radius squared, but I memorize it as pi. Well, let me see. You guys have 2 pi r, right? What is 2 times the radius? The diameter. So I actually memorize it as pi times d. They're the same thing, right? It's going to give you the same exact value, but this is what I memorized for my formula. I don't care which one you are, but if I ask you for which one you memorize, but if I ask you for area, you need to use this formula. If I ask you for circumference, you need to use one of these. Don't use this for circumference. Your units are not squared for circumference. All right, applying formulas or using formulas for example 1. Find the perimeter, area, and or circumference. Circumference is perimeter. It's just the word that we use for a circle. Of a given figure, round to the nearest hundredth if necessary. The first couple ones aren't so bad because they're all numbers. Then we start getting into some with variable expressions. So for our rectangle, that's easy. The perimeter is 2 times 17 plus 2 times 5. 34 and 10 is 44 centimeters. Make sure you put units. If it doesn't have a unit, then write units if it doesn't have a unit of measure. What's my area for this one? 17 times 5, which is 85. 85 square centimeters or centimeters squared, correct. Any questions on letter A? Letter B is a square. I treat it the same way I do with a, when I'm doing area, length times width, but you could just say 4.5 squared because in fact that is what it is. 4.5 by 4.5. Perimeter, you could just do 4s. 4 times 4.5. So the perimeter is 18 inches. The area is 20.25 square inches. All right. Letter C, I want to find the circumference because that's the word we use for perimeter of a circle. That's just pi times d. Pi times d. In other words, the exact value would be 24 pi. And when we get to our unit on circles, sometimes they actually ask for an answer in terms of pi. That would be my answer. It's exact. Unfortunately, if you said, well, how long did you have to walk when you walked around that tank or that cylindrical tank or that cylindrical silo? And I'd say, oh, I walked 24 pi. You'd be like, what the heck is that? So we need to multiply that out. There is a pi key in your calculator. It is often the same as the caret key, second caret. For people with graphing, it'll be above the division key. For people with scientific, I think it's above your x squared or near your x squared on the left side. It's your caret key, though, yes. So we have, it's your power key. So 24 second and caret gives me 24 pi. We don't want to use a decimal approximation unless they tell us to use a decimal approximation for pi. It said round to the nearest hundredth. So if this is 75.3982, what am I going to round to? 75.40. I go to round to there, and I go to the 8, so I have to bump this up, which makes it 4.40. So I'm going to put circumference. Oh, by the way, that is roughly. I use the squiggles to say it's an approximate answer, 75.40. By doing the 0.40, I indicate that I did go to the hundredths, even though it's the same as 75.4. Our area is pi times the radius squared. What is our radius for this thing? 12. It's half of the diameter. Diameter is always twice as big. So exact value would be 144 pi, since 12 squared is 144. But they didn't ask for that. They said give us an approximate answer, round your answer. So 144 pi, or pi times 12 squared, is 452.3893. So it'll be 452 nope, 0.39. 452.39. And I forgot to put my units on these. Which one will have meters? The circumference. Which one will have meters squared? or square meters the area.
So, Mr. Ritter, did you get the 144 from multiple?
From doing 12 squared, yes. Yep. You don't need to worry about that for right now because they aren't asking you to give it in terms of pi or to give an exact value. This is an exact value, but pi has an ongoing decimal, so as soon as I multiply it, I'm going to have to round my answer, which is an approximation. To the nearest hundredth is fine for everyday purposes. If we need it to be precise, most things in your science studies classes are going to be at least 4 decimals out. So the nearest 10,000th would be as accurate as you would need for approximating values usually, if you want them to be more accurate. All right, triangle. We have A, B, and C. What did we say B was going to be? The base. So I'm going to draw this beautiful or horrendous or whatever triangle with the base of 17 and one of the sides is 12 and one of the sides is 2x, yuck. And then the height is 7. Well, the height is always perpendicular to the base. So there's the picture that I draw for this. My perimeter is pretty easy. I just have to add this stuff up. 2x plus 29. And I don't have units, so I'll just put U for units. 2x plus 29 units. If you tell me what x is, then great, I'll actually know what the real perimeter is. But if I don't know x, I can't do it. Area. Area is half of the base, so half of 17 times the height of 7. So I would do 17 times 7 divided by 2. Which is 119 divided by 2 is 59.5. That is an exact value. Even though it's a decimal that ends. It's not an ongoing decimal. And I'd put units squared for that. Example 2 is with variable expressions, which we've already seen a little bit of in the last problem. So we have a rectangle. I always like to draw it so that I can check it and not wreck it. So if 4x is the width, then both of them are 4x. And if 3 minus 2x is the length, then both of them are 3 minus 2x. But if you remember the formula, you're just going to double this, which would give us 8x, and double those, which would give us 6 minus 4x. So our perimeter would actually be 4x plus 6 units. Oh, no, they told us the units were feet, so it's feet. What happened? So I drew the picture, right? So I could go through and add 4x and 4x. Oh, wait a second. What did I do wrong? Oh, that's 8x, right? 8x. Minus 2 is 6. Minus 2 is 4. So 4x. 3 and 3 is 6. But I could also do this. I could do 2 times the width plus 2 times the length. 2 times the width is 8x. 2 times the length is 6 minus 4x. If I were to distribute 2 in. But you can do either one. You can do it this way using the formula, or you could just add up all the sides. You're going to get the same expression for the perimeter. Now, there's 2 things that could happen. You have this equation. I could say, well, now x is 10. Tell me what the perimeter is. So what would you do then? Plug it in. I could tell you the perimeter is 100. What's the value of x? What would you do with the 100? Plug it in for the perimeter and solve for x. But that's not what this is doing. They just asked us to find the answer, which in this case is an expression because we don't know what x is. The area of a rectangle is length times width. I'm going to change it to width times length because that's the binomial. So I have 3 minus 2x by 4x. Oh, I just did length times width. Whatever. That's the same as 4x by 3 minus 2x if you wanted to do it that way instead. You're going to get the same thing either way. When you distribute the 4x times 3 is 12x. What's 4x times negative 2x? Negative 8x squared. Now, if I put it in standard form, I'm okay with this answer, but in standard form, it technically should be negative 8x squared plus 12x, because we always put the highest degree first in standard form. Letter D is a triangle. So we're going to draw our triangle with B as our base. Our base is x minus 1. One of the sides is 3x. The other side is 12. And our height, oh joy, x plus 3. Well, the perimeter is not hard, right? Go around and add up the sides. 3x and x, that's 4x. Negative 1 and 12 is 11. So 4x plus 11. Oh, by the way, because they told us it was feet on our area, we should write feet squared on the outside of that, because it's going to, whatever x is, when you plug it in, you get a number that'll be that many feet squared. That's when they didn't give us a unit, so I'm just going to write units, or U for units. Our area is going to be a little different for this one. We have to do half times base times height. Our base is x minus 1. Our height is x plus 3. How many of you love working with fractions? Nobody raised their hand? So do I want to distribute the 1/2 first, or do I want to do that at the end? End. So I'm going to group my multiplication. I'm going to do these two together first. So this is x times x, which we all know to be x squared. X times 3, which is 3x. This is negative 1 times x, which is negative x. And negative 1 times 3, which is negative 3. That gives me a quantity of x squared. Those two can be combined, so plus 2x minus 3. Now that's just from multiplying those two factors together. Now I have to take this entire thing, which is why I put it in parentheses, and multiply it by 1/2, or divide each of those by 2, same thing. That's going to give me x squared over 2 plus, well, 2x, half of 2x is x, and then minus 3/2. You could also write that as 1/2 x squared if you wanted to. Yes?
Would you mark it wrong if we did 1/2, like we wrote 1/2 x squared?
No, that's the same exact thing.
Okay.
It's the same exact thing. Any questions on that one? All right, flip the page. I would like you to try this for letter C and letter D, please. You can draw a picture if it helps you. If you got the ones on the right, they're there. Any questions on B, D, or F? Yes?
Wait, could you do
D. So the first thing I did was clear the denominator by multiplying by 5. I'm solving for x. So next I undid subtraction by adding y to both sides. So I have 2x equals 5b plus y, and then I divided the whole thing by 2. I could have divided each piece by 2 if I wanted to. It could be 5b over 2 plus y over 2. Would also be correct for that one. Any other questions on B or F? Yes? F. First I cleared my denominator by multiplying both sides by m, so tx equals 5m. And then I'm solving for t, so all I had to do was divide by x. So to clear the denominator, first you multiply by m on both sides. All right, anybody have an answer for C? Yes?
M equals 2 plus S. Or 2.
I think it's negative 2 plus s or s minus 2. Would anyone like to see that one worked out? There's two ways to do it, yep. So the first way to do it is to say, hey, there's that 3 and it's multiplied. I don't like that, I want it gone, so I'm going to divide by 3. That gives me s minus m equals 2. You subtract the s. Some people thought it was a 5, so they got different answers because of that. Negative m equals 2 minus s. And then to get rid of the negative on the m, I either multiply or divide everything by negative 1, changing it to negative 2 plus s. And then in standard form, we put the s first. Letter E. Who has an answer for letter E? Mara.
P equals u over w minus 4.
Almost. You got to get rid of the addition first. So it should be u minus 4 and then divide by w. So here I would take 4 away from both sides. I'd have u minus w equals, or u minus 4, sorry, equals wp. Divide by w, and that would give me this answer. All right, letter A. The volume of a cylinder, which is a 3-dimensional object, we'll be dealing with those at the end of the year, is represented or given by this formula, which you don't have to memorize right now, where r is the radius and h is the height. Solve this formula for h. Well, I start by writing out the formula, pi r squared. What operation is between all of those terms? Multiplication, and I want h by itself. So how am I going to get rid of the pi and the r squared? Divide them away. Now you have to be very careful if we're going to plug numbers in for a calculator. So by doing that, the pi deletes or is canceled out to give us a factor of 1. That cancels out, leaving us a factor of 1. 1 times h is h. So h equals v over pi r squared. Now, what I have to be careful about, and we'll talk about it as we go to do this problem, actually before, if you had numbers, let's say I had this. Let's say I had x equals 6 divided by 2 times 3. We all know what the answer is. What should the answer be? What's 6 divided by the product of 2 and 3? 1. It's 6 over 6, right? Look at what my calculator does if I put it in exactly like that. 6 divided by 2 times 3. It tells me 9. It does order of operations. It divides by 2 and multiplies by 3. So if I have a product in the denominator and I want to put it in my calculator, I have to put it in as 6 divided by, in parentheses, the product of 2 and 3. Or I have to do that separately and then divide. And then it will work. So just be aware of that so you don't get a mistake from using the calculator incorrectly. So in the next part of the problem, so we solved for h. They want us now to use that to find the answer for h. The height of the cylinder, this is its volume. So 2,500 pi over pi times radius squared. The radius is 10, so I plug that in, and that's our height. Now, there's a way you could check your answer. If you're not sure if you did this part correctly, you could plug that stuff into this original equation and solve for h again. That would be fine. But we already have it set up to just plug it in here. So 2500 pi divided by the product of, of pi and 10 squared. By the way, what's going to happen to the pi? It's going to cancel out. But I didn't even think about that. But yes, the pi is going to cancel. I'm going to have 2500 divided by, what's 10 squared? 100. So guess what my answer is going to be? I don't even need the calculator. 25. But I can do it in the calculator. I still get 25. Right here, my pi's cancel. That's 2500 divided by 100. 25 over 1, 25. By the way, this has a problem. This problem is not written correctly. It says the radius is in feet. Is the height going to be in feet since it's a linear measure? Yes. There's something labeled incorrectly in this picture. Anyone know what it is? It says the volume is 2500 pi feet. It should be 2500 pi feet cubed, because volume is cubic units. Unless it's gallons, then that has a relation to cubic inches. Try this for letter B. Don't plug it in yet. Just see if you can solve for whatever they're asking you to solve for. Take a second to solve for what they ask you to solve for. So if you did this correctly, you were solving for B. So you needed to, how do you get rid of 1/2? Thank you. I had some people say, oh, let's divide by half. We don't divide by fractions. To divide by fractions, we multiply by their reciprocal. So 2a equals bh. Divide by h. b is 2a over h. There's our equation with the variables. And now I'm supposed to plug this stuff in. The area is 140 square feet. Plug that in for a. 2 times 140. You don't square it. That's just the units of the measure. The 140 is the number for the area. The height is 12. So that's going to be 280 over 12. And that will give you 23 1/3 for your base. Your base is 23 1/3 feet, I think. No? Yes? Which part, the left or the right? The right. So my formula was 2a over h equals b. So I did 2 times the area. The area was 140, so I plugged that in for a. And the height was 12, so I plugged that in for h. So I did 2 times 140 divided by 12 to get my base. Well, it's in my formula over here, 2a over h. You can use that. If you didn't, then you'd still plug it all in, but you'd have to solve. So you'd have to multiply by 2 and divide by 12, and you would